All right, let's get real for a minute. Back in the ancient times of, early 2024, we were all paying OpenAI something like $20 for a million tokens. Today, you can get the same level of intelligence from a model like Llama 3 for about 20 cents. Yeah, that's a 99% price drop. But here's the catch, and it's a big one: reliability. We're in a gold rush for speed and price, but that comes with some serious hidden risks.
And this quote nails it. We're not talking about a little speed bump here. This is a step change. It's so fast it completely changes what's possible. Think real-time voice agents that don't have that awkward pause. But with great speed comes great responsibility and the potential for things to break spectacularly.
So here's our game plan. We're going to look at the new speed demons on the block. Then we'll dig into what I call the hidden contract, the stuff they don't tell you about reliability and rate limits. We'll map out the threats, not just from hackers, but from the providers themselves. We'll talk about building a resilient pipeline, why you need to adopt a zero-trust policy for your vendors, and finally, how to be both blazing fast and completely bulletproof.
Okay, let's kick things off with the performance revolution. And I mean, the numbers we're about to see are just nuts. This is what's forcing us to rethink our entire AI stack. 1,800 tokens per second. Let that sink in. This isn't for some tiny model. This is on Llama 3.1. So what's this good for? This is your workhorse for massive throughput. If you're summarizing 10,000 documents for a RAG pipeline, this is your guy. It's all about getting a huge amount of work done, fast.
And here's why we're all paying attention: the cost. 10 cents per million tokens. For a startup, that is an absolute game changer. Suddenly running a billion token workload a month isn't a $5,000 bill from OpenAI, it's a couple $100. The economics have been completely flipped on their head.
So you've got two main speed demons right now. Groq is the king of low latency. If you're building a voice bot where every millisecond of delay kills the user experience, you pay the Groq premium. On the other hand, you have Cerebras, which is all about raw throughput. It's a 20x jump over standard GPUs. It's not about one being better. It's about picking the right tool for the right job.
And this is the so what. Speed isn't just a vanity metric. It unlocks entirely new products. You can't build an intelligent answer engine that feels like a real conversation if it takes 3 seconds to respond. This is why we're obsessed with performance. It's the foundation of the next wave of user experiences.
All right, we've seen the dream. It's fast, it's cheap. So what's the catch? Because there's always a catch. This is what I call the hidden security contract. And I'm not just talking about hackers. I'm talking about business risk, the stuff that takes your app offline at 3 a.m. Let's rephrase this question from a startup's point of view. Sure, we care about attackers, but what about the provider itself? What happens when your dirt-cheap provider silently starts rate limiting you during peak traffic because they're running on overloaded consumer GPUs? That's an attack on your uptime, and it's far more common. Gartner says we need to protect these things like autonomous machines. And I agree. You wouldn't put an autonomous car on the road if its core systems could just shut down randomly, would you? The same goes for our AI agents. They need to be protected from all threats, including the unreliability of the very infrastructure they run on. So the security community has given us a great map for traditional threats with the OWASP Top 10 for LLMs, and that's important for sure. But we need to expand our definition of the threat landscape. Look at this map. It covers things like prompt injection, data poisoning, all valid concerns. But where's the item for provider hits capacity and your production app dies, or vendor uses spot instances that vanish mid-request? For a startup, those are the threats that keep you up at night. They're just as critical.
So yeah, you absolutely need to sanitize your inputs to prevent prompt injection, and you better handle the output securely. But honestly, these are table stakes application security. We've been dealing with variations of this for decades.
Now we're getting warmer. Model denial of service. A cheap provider who can't handle your load is basically performing a DOS attack on you. Supply chain vulnerabilities? That's exactly what you have when you bet your entire company on a single, low-cost provider without a backup plan. You've introduced a massive single point of failure into your supply chain.
This is why we have to think bigger. Securing AI isn't about the model. It's about the entire pipeline that gets a user's request to a model and back again. It has to be resilient from end to end.
When I look at this pipeline, I see multiple points of failure. The platform and runtime stages are critical. If your platform is just a direct API call to a single vendor, your entire production environment is fragile. It's not secure in the broadest sense of the word.
So what's the architectural equivalent of these security controls? It's not just container scanning. It's building a router, a proxy, Something like LiteLLM that sits in front of all these commodity providers and lets you load balance, failover, and route traffic intelligently. That's the real security control for your AI service.
And that brings me to the zero trust mandate. In networking, zero trust means never trust, always verify. I'm applying that to our vendors. Do not marry a single provider. They are commodities. Trust none of them to have 100% uptime when you need it most.
This slide shows it perfectly. The architecture on the left, that's you hard-coding your app to call one provider's API. It's insecure, it's fragile. The one on the right, that's a sandboxed, controlled architecture. In our world, that means a router like LiteLLM is in the middle, treating each provider as an untrusted, isolated resource that can be swapped out at any time. Let's translate this to vendor management. Sandboxing? That's your router isolating providers. So if DeepInfra goes down, it doesn't matter. Traffic just fails over to Groq. Admission control? That's your router logic deciding which requests go where. Voice traffic with low latency needs goes to Groq. Complex JSON for an agent goes to Fireworks AI. Continuous monitoring? That's your router tracking the latency and error rates of every provider in real time.
This zero-trust multi-vendor approach solves all of these business risks. Your request pipeline is no longer insecure because it can fail over. Your supply chain isn't dependent on one vendor. And you gain massive observability into which providers are actually delivering on their promises. So this brings it all together. The goal isn't just to be fast. The goal is to be fast and fortified. And fortified means resilient, cost-effective, and architecturally sound. That's how you build something that lasts. And let's be crystal clear about this. Speed and reliability are not trade-offs. They are code-dependent. The fastest model in the world is useless if its API is down. You need an architecture that gives you access to the best speed, at the best price, with the best reliability. That's the holy grail. So I'll leave you with this. The models are getting faster and cheaper every single week. It's a commodity market now. The question is no longer just about security. It's about your architecture. Are you building a smart system that can take advantage of this market? Are you building for resilience? Is your architecture keeping pace with the revolution?